Hi, I'm Morgan By, and today I thought I'd take a few minutes to just walk you through a couple of the features of PowerSat version 12.8. So, as you'll probably already be aware, for those of you that don't already know, PowerSat, which I call is short for power saturation curves, is a pretty well documented feature of the EPR toolbox. So if you go to morganby.net and go type on PowerSat, you'll see that there's a whole website listing all sorts of features of the program. I thought it might be nice to actually show you a couple of examples in video format. So here in this folder I've just got a couple of files. So I've got an oxygen file and a nitrogen file and a nickel file and a dp.8 standard that I've all run under exactly the same conditions. So now I've got my power saturation experiment done, I think it's time to analyze it. So I've already navigated to the same folder in my MATLAB, and I've set that to the current window. So now, because the PowerSat is already on my active path, I can just type PowerSat, and you'll be presented with a nice window like this. So immediately what you'll see from PowerSat is that it's quite a small self-contained object and window, and everything you could possibly really need is all in one place straight away. Forgive the little pop-up, it's because I keep zooming in and out for you. So what most people will be doing is very simply wanting to analyze some data. So the very start, you want to load some data, so you click on load datasets, and because I've got three-dimensional files, they're the Brookle file with a .ygf format, so I can just click on that, and we've got a nice little GUI pops up straight away. And straight away, because I clicked on the oxygen, I'm going to load the oxygen file. And as soon as you click load a file, it will pop up instantly in the viewing window over here, and then you'll be presented with this little fitting window in the middle, which should nicely fit all of our data. And once that's finished fitting, you should see that it instantly redraws this with a few extra lines, and it also plots all of the data points over here into a nice power saturation curve, and then it's automatically plotted or fitted the power saturation equation, which is in the program help from an Attle and Back paper. And then it chucks out all of the parameters of the fitting. So from this oxygen curve here, we can see that we've got a p-half of 8.6316. If we just zoom in like that, the error is pretty good, and it also gives you the other fitting parameters there. So that by itself is very nice, but that by itself doesn't mean very much. So what we're going to do is load a second data set. So we click on load data set. We go down to load nitrogen, and we load a single file. So I now select my load N2, click OK. Once again we have a little progress bar come along, and it will fit each curve, or each spectrum rather. And once again we see that the lines, the dotted lines here, are the outer lines of our fitting window as determined by this here. And then because the blue label here for nitrogen is then turned us into a nice blue curve there. And if we look down at the bottom, exactly as we'd expect, the p-half value for this is much less, which is exactly what you'd hope for the spin label that I've been looking at. So finally, we can load our other data set, the nickel EDDA, and once again we'll go through the fitting, and as you can see I've obviously got 45 data points from here across a variety of microwave powers. Quite boring, I know. And there we have our third curve, and that's given us quite a nice curve with a p-half value of 26.7, which is exactly what we expect. So finally, if we load our final data set, DTP-H standard, and we just load that. Now this is a standard, so I didn't run as many powers, and that's not quite as important, but as soon as you load the DTP-H standard, you'll see that in the background a load of maths is done, and we see that once we have our known standard we can complete all of the maths, and we can see that right down here at the bottom that our oxygen, well, although our spin label has a 16.7% accessibility to oxygen, and it has a 63.7 accessibility, or 0.637 accessibility parameter to nickel, which, considering I know that this spin label is very much a solvent exposed and is open to water, then this is exactly what I'd expect from this spin label. So there you have it. There's some very basic features of power saturation, version 12.8. If for some reason you'd like to take these curves and export them somehow, there are several options for you. You can simply click on export variables to workspace, and if I do so, you'll now see that over here that we actually have a nice selection of parameters straight there. And if I open one of these at random in your variable editor, you'll see that you've got the y-axis and the square root of power for the x-axis, and you actually have the fitting results as well for the different parameters. But that's nice if you're actually doing some sort of compiling, but more than likely you'll probably actually want to plot that in some other graphical program. So for that reason you can just click detach plot, and then it opens the plot as an external window, and then as per any other figure in MATLAB you can then save it as anything you like, as a EPS if you're an encapsulated PostScript fan, or PNG, or just a simply MATLAB figure. And there you have it. That's a very quick guide to power saturation, version 12.8. If you'd like to know any more information, then feel free to go to morganby.net/PowerSat, and all of these files are available from sourceforge.net, where I host all of these files if you'd like to download them. Thanks very much for your time.